So I had a couple parents ask if we could get a little bit of help with this algebra. So I'm going to actually go over this algebra test review, and please use it to help review with your child, or your child can just watch it. So the first part of the test is going to have to do with order of operations. For this, it's the specific order they need to solve the problem in. So we've learned about please excuse my dear Aunt Sally. That stands for parentheses. In 5th grade, we don't need to do exponents. Multiply, divide. The only thing about these is that we do whichever one comes first from the left to the right, and then the A and the S also go together, and it stands for adding and subtracting. We do whichever one comes first from the left to the right. Another strategy I've taught them is we've got a little parentheses man, so you'd first do the parentheses, then you either multiply or divide, again from the left to the right, so his hands are on the same level, and then you either add or subtract. Again, his feet are on the same level, so you're going to be working from the left to the right. So when I see this problem, what I like to do is rewrite the whole problem, and I'm going to start by underlining the first thing I'm supposed to do. So here I see that I have a parentheses, so that means I need to do this first. So I'm going to do 4 plus 2 is 6. I cross it out afterwards, and then I rewrite everything that I have left, so I know what I still need to solve. Then I have a subtracting, dividing, and adding. Well, if I look at my parentheses man, the dividing comes before the subtracting. So I'm going to divide 6 divided by 2. That gives me 3. Again, cross it out, rewrite the rest of it. Now you have subtracting and adding, which again are on the same level for PEMDAS. So you're going to do the one that comes first. So subtract 24 minus 3, that's going to give you 21, plus 1 is going to give you a final answer of 22. And so those are the steps that you would need to solve to do order of operations. So I'm going to leave B, that way you and your child can kind of work through it and hopefully follow those same types of steps. Then the next section of the test is going to have to do with patterns. So for patterns, you might see one like this where it says how many blocks would be in the 5th shape. So first thing you have to know is this is shape number 1, and I'm just going to write SH for shape. So shape 1, this is shape 2, and this is shape 3. So you're going to have to figure out what shape 4 would be, and then figure out what shape 5 would be. So first thing I'm going to look at is there's only 1 block in the first one, there's 3 in the second one, and then there are 6 in the third one. So if I think from here to here, how much did I add to go from 1 to 3? I added 2 more. Then to go from 3 to 6, I added 3 more. So this is what we've learned about is called a growing pattern. So it's just going to keep getting bigger and bigger. So if I'm adding 2, then 3, next I would need to add 4. So if I'm adding 4, I had 6 plus 4 more. Shape 4 is going to have 10 blocks. And then I'm going to have to add 5 more. So then I'm going to do 10 plus 5 more. My shape 5 is going to need to have 15 blocks. And so what they really did is each time they added an extra row, they put, here's the 2 they added, here's the 3 they added. So if they actually were to draw the shape, this is what shape 3 look like. So shape 4 would just need to add 4 blocks in the last row. Shape 5 is going to look like shape 4, but it's going to have, again, that extra 5 on the end to continue this almost like little staircase pattern that we've got going. So patterns can sometimes be with numbers as well. This section of the test, the students are allowed to use a calculator. So here I can see that going from this number to this number, I'm getting smaller. So I've taught the students to think about if this is dividing or if it's subtracting, because if my number is getting smaller, I'm either dividing or subtracting. What I'm going to do is I'm going to take out my calculator, and I am going to use that to see if it looks like dividing or subtracting. Subtracting is much easier to test first. So I'm going to do 3.44 minus 3.11 and to see what the difference is between the two of them. So there it's 0.33. So to test if that's what I'm subtracting, I'm going to do the next number, 3.11 minus 0.33, and see if that gives me the next number in my pattern. So if I do subtract 0.33, and then again I subtracted 0.33, I did get 2.78, so now I know my rule is each time I need to subtract 33 hundredths. So then to figure out the next numbers, I can use my calculator, 2.78 minus 0.33. That's going to tell me my next number is 2.45. Then again, I'm going to take that number and subtract 0.33, and that gives me 2.12. So that would be how I would do a pattern type question using a calculator or using the blocks. For a problem like this, what the students are supposed to be doing is, this is almost like what we call an in-out box, where you're having to read the chart and figure out what it's showing. So this William's age, when he was 0 years old, he weighed 6 pounds. So when he was born, he was 6 pounds. At 1 month, he was 7 pounds. 2 months, he was 8 pounds. And 3 months, he was 9 pounds. So I have to look at choice A, B, and C and figure out which one's describing it. Did William gain a pound a month? Well, from here to here, I added 1, and from here to here I did add 1. But then I'm going to look at my other choices. William started at 6 pounds, so when he was born, he started at 6 pounds. That's true, and then he gained a pound a month. Or William gained 6 pounds every month. Nope, he definitely doesn't gain 6 pounds every month. So although A is true, that when I go from the months, the best answer is that he starts at 6, because he doesn't go from being 0 pounds to 1 pound to, or 2 pounds to 3 pounds. He starts at 6 pounds. So I would have to pick B for there. Then for this next type of problem, it says what equation means y more than 9? So if I look at my choices, if I'm saying more than, I need to be picking the one that's adding. This would mean 9 less than y. This would mean 9 divided by y, and this would mean 9 times y, or multiplied by y. So the one that's more than, I'm adding. Here's another one of these chart type problems. So here I've got the T, and I'm going to the C. So I'm starting with how many tickets I need to buy, and then going to the cost of tickets. So here, I need to think, for if I start with 1, and then I end up with the answer of 5, what am I really doing to it? So here it says T plus 5 equals C. So if I have my T is 1, does 1 plus 5 equal to 5? Nope, so it can't be that one. Then I would try the next one, 1 times 5. So if I do 1 times 5, will that give me 5? Yes. So let me test it out with the next one. Does 2 times 5 equal 10? Yes. And then the last one, does 3 times 5 equal to 15? Yes. So this is a multiplying. You have to take the cost of the ticket, multiply it by 5 to get the total cost. I'm going to skip going over H because I feel like this is similar to a problem that we've had above. We're going to talk about this in-out box again. This is similar to what we just did. So again, I need to start with my in box and then figure out what did I do to it to get to my out box. So here I'm going from 12 to 6. Automatically I know that means my answer is getting smaller. And like I talked about above, if it's getting smaller, it's either subtracting or dividing. So I automatically need to rule out the one that says multiplying. Then I need to just test each of these rules out. Is 12 divided by 2 going to give me 6? The answer is yes. Is 24 divided by 2 going to give me 12? Yes. Does 30 divided by 2 give me 15? Yes. Does 4 divided by 2 give me 2? Yes. So that is my rule. 12 minus 6 would give me 6, but if I did 24 minus 6, I'm not going to get 12. So that doesn't work. And again, 12 minus 2 is not going to give me 6. So the only rule that makes sense there is that one. I'm skipping going over J. I felt like that was a problem the kids have been doing pretty well in class. This one is, what does this model represent? So for these types of questions, a lot of times we call these equation mats. They'll usually have a key off to the side, like a cup or some bigger rectangle is equal to X, and that the circles are equal to 1. And so what this problem is showing is that you only have one box. So I can't pick the one that says 2X because I don't don't have two x's. I only have one x. And then I've got two circles. I'm not subtracting the two circles. I'm actually adding the two circles. And then on the other side, I have 5. So this problem is representing that I have 1x plus 2 circles is equal to 5 circles on the other side. If we were to solve for x, this would be x plus 2 equals 5. And the students have been able to figure out that x would equal to 3 because 3 plus 2 is 5. But when they see a question like this on the test, they are not supposed to solve it. They're just supposed to tell me what the equation is that's being represented. The next one, they have to match the word problem to the actual problem. So again, this n, this variable, just means that I don't know what it is. So I have to think about which one of these word problems sounds like a division problem, where I started with 45 of something, then I divided it into some number of groups, some number that I don't know, and I ended up with 15 in each group. So this A says there were 45 balls, then some of them get lost, and now there's only 15. This is a subtraction word problem. If some are getting lost or taken away, that's subtraction, so I should not pick that. Letter B, there are 45 candies and they get split into bags. So again, this word split gives me a clue. This is probably a division problem. Each bag had 15 candies. How many bags? This is my unknown. I don't know how many bags I had, so that's probably the answer, but I'm going to keep reading. There were 45 eggs hidden, and then Grandma did 15 more. This means this is an adding problem. So the correct answer would have to be B, because that's the only one that's worded in a division problem. Again, we're going to go ahead and skip letter J down here. I think the kids were pretty good at figuring out types of problems like this. We're going to just look at this pattern one. This is another one. They could technically use the calculator. It's probably not going to help as much for something like fractions. They need to think, okay, am I getting bigger or smaller? This time I'm getting bigger. So if I'm getting bigger, again, it's either an adding or a multiplying. It is easier to start with the adding. So I'm going to say, if I had 1.5, what would I add to it to get to 2? Well, I would need to add 1/2 to it. Now I'm going to see if this is a repeating pattern. If I go from 2 to 2.5, yep, I'm adding another half. 2.5 to 3, yep, I'm adding another half. So my rule is add half. So if I do 3 plus a half, I'm going to get 3.5 for my next number. And if I add another half to 3 1/2, I'm going to end up with 4. And so that is how I would complete this pattern. I'm not going to go over the bonus. They're not going to see anything like that on the test. And I hope that this was helpful.